Hi everyone, welcome back to all of you on my YouTube channel. So I'm Ankit Mishra. I'm teaching for GATE chemical experience for last 4 to 5 years. So here you can see that I'm coming with PYQ series of all of these subjects. So I'm continuing with the fluid mechanics right now. So in the previous lecture I have started discussion of PYQ about the fluid dynamics, and the last question I have done some mistakes in that calculation. So again I'm solving this question, and you can learn these things from here only. So the question says that a cylindrical tank with a diameter of 500 millimeter. So here you can see this diameter is 500 of the tank's diameter, and a 5 millimeter diameter round nozzle. So here you can see the nozzle's diameter is 5 millimeter, whose center is 1 centimeter. So the center is above the 1 centimeter from this bottom line, right? So the pressure above the water level in the tank is maintained at 2 bar, that is absolute pressure, and neglecting all the frictional and exit entry loss. Use acceleration rate to gravity is 10 meter per second square, and atmospheric pressure as 1 bar. The absolute value of, you are supposed to calculate the value of dH by dt when t equals to 0 in millimeter per second, right? So let's try to understand how we can solve. So let's say if I'm assuming this point is 1, and at this point if it is 2, and I can apply the Bernoulli's equation, right? So I can say P1 by rho g plus B1 square by 2g plus Z1, that is equals to P2 by rho g V2 square by 2g plus Z2, right? Now P1 is given to you 2 bar, so I can write 2 into 10 to the power 5 Pascal divided by rho is 1000, and gravity is g, and V1 is 0 plus Z1 minus Z2. So Z1 minus Z2 will be what? Z2 is 1, Z1 is h, that is 51, so that can be 50 centimeter divided by 100, and that can be P2. P2 is your atmospheric pressure, that is 1 bar. So 1 into 10 to the power 5 divided by rho g, that is 1000 into 10 plus V2 square by 2g. So we are supposed to calculate the V2 first. Once you will calculate V2, then we can calculate only a dH by dt, right? So from here you can say that V2 square by 2g value you will be getting 10 to the power 5 divided by 10 to the power 4 plus 0.5. So that is 10 plus 0.5, that is equals to 10.5. So what is the value of V2 here? V2 will be 10 multiplied with 2 multiplied with 10 multiplied with 10.5. So that will be equals to 20 multiplied with 10.5 root over. Is that clear? So once you do the calculation, let's try to do the calculation here. So 20 multiplied with 10.5 and root over. So the value of V2 will be 14.49 meter per second. Okay. So now once you get the value of V2, now you can write the value of area of cross section of the tank A dH by dt is equals to, let's say A1 dH by dt is equals to A2 multiplied with V2, and A1 you don't know. A1 is the height of the tank, area of the tank. So dH by dt, that will be equals to A2. A2 is how much? Pi by 4 into 0.005 whole square. So directly I will be writing 0.005 whole square divided by 0.5 whole square into V2. V2 is how much? 14.49. Is that clear? So once you do the calculation, you will be getting the value of dH by dt at t equals to 0, that will be equals to 1.4449 meter per second, that will be equals to 1.45 meter per second approximately. Is that clear? So you will be getting this value from this particular problem. Okay, I hope this is clear to all of you. So here I am going to end the fluid dynamics, and after that I will be talking about the fluid through pipe. That is also very important topic, and you will see lots of questions that has been asked in GATE from this particular topic, especially in fluid mechanics. And obviously this topic is very important for both XC paper, those who are writing GATE in XC paper, and those who are writing GATE in mechanical engineering, right? So the first question says that in a fully turbulent flow in a pipe of diameter d for a constant pressure gradient, the dependency of volumetric flow rate of the incompressible fluid is. So here you can see you are supposed to calculate pressure drop is constant, and you are supposed to understand the dependency of volumetric flow rate with the pressure, this thing. So when I am talking about the pressure drop delta P divided by L in case of turbulent flow, so that will be equals to 1 by 3 FL Q square divided by d5. Is that clear? So since pressure drop is constant, okay, and for fully turbulent flow, so you can say Q square is directly proportional to d5. So Q will be directly proportional to d to the power 2.5. Is that clear? Q will be directly proportional to d to the power 2.5. Okay. Okay, then I'll be moving to ask the next question. Next question says that a hydrocarbon oil having viscosity is given to you and density is also given. It is transported using a 0.6 diameter 10 kilometer long pipe. So there is pipe and hydrocarbon oil is there, and the length of this pipe is 10 kilometer and diameter of this pipe is 0.6. 0.6 meter. The maximum oil pressure drop across the pipe length is 1 megapascal. So it has been given that delta P divided by L is equals to 10 to the power 6 pascal pressure drop per unit length. Across the pipe length, 10 kilometer pipe length is there, then throughout the length 10 to the power 6 pascal pressure drop is there, let's say, okay. And due to the maintenance schedule on the pipeline, it is required to use 0.4 diameter and 10 kilometer long. So now what is happening here? So due to the maintenance schedule, now it is suggested that now you can use only 0.4 meter diameter and again length will be 10 kilometer, right, pipe. So let's say this one is case first and this one is the case second. And diameter pipe. Assume both pipes have same both pipes to be hydrodynamically smooth and there is a range of operating condition. The finding friction factor is given by this one. So estimate the pressure drop for the 0.4 millimeter diameter pipe, right? So since you can see that if I am talking about pressure drop and this thing, viscosity is also given to you and Reynolds number. Pipe is hydrodynamically smooth and fanning friction factor is given as F is equals to 0.079 into Re whole to the power minus 0.25, right? So you have to calculate the pressure drop here and pressure drop here. So what is the ratio of delta P1 divided by delta P2? So what is HF? That is equals to 1 by 3 FL Q square divided by D5. And what is delta P? Delta P is rho Z HF. Is that clear? Okay, so directly if I say that delta P is directly proportional to HF, means delta P is directly proportional to Q square, F into Q square divided by D5, and F is directly proportional to how much? Re to the power minus 0.4. So Re to the power minus 1 by 4. So F will be directly proportional to D to the power minus 1 by 4. Is that clear? So since flow rate will be same, obviously, so only you can say that delta P is now directly proportional to d to the power minus 1 by 4 divided by d to the power 5. So delta P will be directly proportional to d to the power minus 1 by 4 minus 5. So delta P will be directly proportional to d to the power minus 5.25. Minus 5.25. Sorry, here it is minus and minus, so f is directly proportional to 1 upon the rho vd, so minus 0.25 and plus 4.75. Okay, so now you can directly calculate delta P1 divided by delta P2, that is equals to 0.6 divided by 0.4 whole to the power 4.75. So delta P1 is given to you 10 megapascal divided by delta P2, that is equals to 3 by 2 whole to the power 4.75. So finally you will be getting delta P2, that is equals to 6.861 megapascal. Okay, so this is just a calculation here, you don't have to do anything, that's it. Okay, after that I'll be moving to ask the next question. The next question says that the operation of a rotameter is less than, obviously this is variable area meter, so if I say the diagram of rotameter, it looks like in this way, where there is a float, and after that due to this particular float you can see there is a tapered cross section, and due to this particular region area is going to get varied, and the operation is based on the this thing. So here only you are if you make the free body diagram of rotameters, that is rotor, so there will be mg, and again there will be buoyancy force, and one there will be a drag force. So these three forces are acting in case of rotameter in order to calculate the flow rate of fluid through the rotameter or pipe. Now moving to the next question. The next question says that the pressure difference across a vertical venturimeter is measured with the help of the mercury manometer to estimate the flow of water through it. The expression of the velocity of the water at the throat is. So let's try to understand this thing. So in this diagram, if I see this level is there one, another level is this one, and another level is this one. So let's say I am assuming this one is h1. Is that clear? So where this point 1 will be there. So this is your point 1, and at this point this is the point 2. Is that clear? So if I say that if I want to maintain the pressure at this particular limb, so pressure at this point here will be equals to pressure at this point, right? So what I can say that P1 divided by rho W Z plus so I can say P1 plus rho W Z H1 plus rho W Z H, that is equals to what? P2 plus rho W P2 plus rho W H plus capital H into Z plus rho M Z H. Is that clear? So from here I can calculate the value of P1 minus P2, that is equals to what? Rho W H Z plus rho W capital H Z plus obviously rho M Z small h minus rho W Z small h. So rho W G small h will get cancelled out. So I can say P1 minus P2, that is equals to rho W minus rho M. I can say rho W Hg plus rho M Hg. This one is the one equation. Sorry, I did one mistake here. So it should be H1. So now if I want to calculate P1 minus P2, that can be written as rho W H1G plus rho W Hg plus rho M Hg minus rho W ZH1 minus rho W ZH. So rho W ZH1 will get cancelled out. So finally you will get P1 minus P2, that is equals to rho W Z capital H minus H plus rho M Hg. This one is my equation first. Okay, and now if I apply the Bernoulli's equation at point 1 and 2, so I can say that P1 divided by rho Z plus V1 square by 2Z plus obviously Z1, that is equals to P2 divided by rho Z plus V2 square by 2Z plus Z2. So obviously P1 minus P2 divided by rho Z can be written as V2 square minus V1 square divided by 2Z plus Z2 minus Z1. And what is Z2 minus Z1? That is H. And P1 minus P2 by P1 minus P2 is what? Rho WZ. So this is rho W. Is that clear? So now I can write P1 minus P2 divided by rho W Z, that can be written as H minus H plus rho M by rho into H, right? So I can write H plus, if I take common, so I can write rho M by rho minus 1. Is that clear? So finally I can write H plus H into rho M by rho minus 1, that is equals to V2 square minus V1 square divided by 2Z plus Z2 minus Z1 is H. So H will get cancelled out. Finally you will be getting V2 square minus V1 square divided by 2Z, that is equals to rho M by rho minus 1 into H. That's it. Okay, so this will be your answer. This was a bit hectic question and difficult question, but again if you will do this thing, then definitely you are going to get the answer. So that is rho M by rho W. So your option B will be your correct answer. Okay. After that, I'll be moving towards the next question. The next question says that 3-pipe network as shown in the figure are placed horizontally. They are made using identical pipe segment and subjected to the same pressure drop across them. Assuming no pressure losses at junction, the flow rate across the three sections are related as Q1, Q2 and Q3. Okay, great. So here you can say if I am assuming this length is 2L, so this length will be here L and this is L, and again this length is L and again this length is your L. Okay, so if I tell you that this segment pressure drop across them, so nothing is given here, but if we apply the Hagen-Poiseuille's equation, delta P by L, that is equals to 32 mu U bar L divided by dA square, right? So here you can see delta P is directly proportional to L. Is that clear? And what is U bar? U bar is equals to Q divided by area. Is that clear? And delta P is directly proportional to U bar, means delta P is directly proportional to L multiplied with Q divided by area. Is that clear? But the diameter of the pipe is same. Is that clear? So from here what I can say, Q is inversely proportional to 1 upon L, because pressure drop in all of these pipes are same. So if I say that Q1 is directly proportional to 1 upon 2L, Q2 is directly proportional to 1 upon L, Q3 is directly proportional to 1 upon L. So if I calculate ratio Q1 is to Q2 is to Q3, so that will be equals to 1 by 2L is to 1 by L is to 1 by L. So this will get cancelled out. So finally you will get Q1 is to Q2 is to Q3, that is equals to 1 is to 2 is to 2. So this ratio will be there. Is that clear? So this is just based on Q, that is flow rate, is inversely proportional to the length of the pipe, right? So if length is large, flow rate will be small. If length is small, flow rate will be large. Why? Because if you use the Hagen-Poiseuille's equation, the formula looks like that. So from here you can see your option C will be your correct answer. After that, I will be moving towards the next question. The question says that a fluid is pumped at a flow rate of Q through a pipe of length L. The pressure drop of the fluid across the pipe is delta P. So let's say you have a pipe here something diameter is this one, let's say d1, and the pressure drop is delta p here in first case. In the second case, now a leak develops. So here, if this one is your pipe, like, so this leak got developed, and after that you can see that some flow rate is happening through this and some flow rate is happening through this. But here, after a L by 2 distance from here, this one is L by 2 and this one is L by 2, and again if it was Q, so here now flow rate will be going Q by 2 and flow rate here is Q by 2, right? So flow rate is getting divided because the symmetric condition. Is that clear? The new pressure drop across the pipe for the same inlet flow rate Q is, so here same inlet flow rate is Q, and if I am assuming the pressure drop here is delta P2, right, and here pressure drop is delta P, so what is the delta P2, right? So if I am talking about delta P here, so delta P is directly proportional to what? Q. Is that clear? So if I write delta P divided by rho g, that is equals to 1 upon 3 FLQ square divided by d phi. Right, diameter is same, so you can see delta P is directly proportional to Q square from this equation. And in the next case, what you will see that here delta P will be equals to what? So if I am assuming that 1 by 3 FL divided by d5 is constant K, so delta P divided by rho g, that will be equals to KQ square. Is that clear? This one is my equation first. And from another case, delta P2 can be written as obviously 1 by 3 FL by 2 and Q by 2 whole square divided by d5 plus 1 by 3, sorry, here it is Q square only, 1 by 3 FL by 2 and now Q by 2 whole square divided by d5. Is that clear? So finally you can say delta P2 is equals to, I can write 1 by 3 FL Q square divided by d5 into 1 by 2 plus 1 by 4 into 1 by 8 FL Q square divided by d5, right? So finally if I take common Q square, so delta P2 can be written as K, and obviously your Q square by 2 plus Q square divided by 8, so that will be equals to K into 5 by 8 Q square, right? So if I delta P by rho g, so if I divide equation first and equation second, so I can write delta P by delta P2, that is equals to KQ square divided by KQ square into 5 by 8. So this will get cancelled out. I can write delta P2 will be equals to 5 by 8 delta P, means the pressure drop will get reduced by a factor of 5 by 8 only, right? So from here you can see your option B will be your correct answer. Okay. Okay, now moving towards the next question. The next question says that a pipeline system carries crude oil of density 8000 kg per meter cube. So here density of this fluid is given 8800 kg per meter cube. The volumetric flow rate at point 1 here. So here volumetric flow rate is given 0.28 meter cube per second. The cross sectional area of this point is given at 1, 2 and 3 is given to you. All the three branches are in horizontal plane, means there is no difference in elevation of this point 1, 2, 3. If the pressure at point 1 and 3 are this one and this one, then the pressure at point 2. Okay, so you are supposed to calculate pressure at point 2 and point 2. Okay, so definitely in order to calculate the pressure, you have to use the Bernoulli's equation first. Second thing is that if I want to write Q1 can be written as Q2 plus Q3. This one is our equation first. And cross sectional area is given to you and you can calculate the velocity at point 1. So what is b1? b1 is equals to q1 divided by a1. So what is q1 there? q1 is obviously 0.28 divided by 0.012. So the value of v1 from this particular equation you can get is 0.012. So value of velocity at point 1 is 23.3 meter per second. Okay, great. Now after that what I can get is, if I apply the Bernoulli's equation at point 1 and 2, so but you are supposed to calculate the velocity at that point also, right? So okay, so apply Bernoulli's equation at point 1 and 3, right? What I can say, p1 by rho g plus b1 square by plus z1, that is equals to p3 by rho g plus v3 square by 2g plus z3. Elevation is same, so z1 and z3 will get cancelled out. So p1 is given to you 270 and p3 is given to you 240. This is in kilopascal, so I'll convert, and rho is 800. Density of the fluid which is flowing through the pipe is 800. So 800 multiplied with acceleration due to gravity, I am assuming is 10, plus b1 square. b1 square is 23.33 whole square divided by 2 into 10, that is equals to v3 square divided by 2z. So from here I can calculate the v3 square. So value of v3 from here you will be getting 24.88 meter per second, right? Now once we get the value of v3, you can calculate the value of v2 also, right? So I can write a1 b1, that is equals to a2 v2 plus a3 v3 while using the continuity equation, and that is 0.28, that is equals to a2. a2 is also given to you 0.008 multiplied with v2 plus a3 is given as 0.004 and v3 is 24.86, right? So from here you will get value of v2 will be equals to 22.55 meter per second, right? So once you get the value of v2, now you can apply at point 1 and 2. Now we can say that p1 divided by rho g plus v1 square by 2g plus z1, that is equals to p2 divided by rho g plus obviously v2 square by 2g plus z2. So you are supposed to calculate the value of p2, right? So directly I can say that p1 divided by rho g plus v1 square minus v2 square divided by 2g, and z1 z2 will be same level, so that can be written as p2 divided by rho g. So the value of p2 can be written as p1 plus b1 square minus v2 square divided by 2 into rho. So p2 will be equals to how much? The value of p1 is given to you 270 kilopascal, 270, this is in kilopascal, plus v1 square. So v1 is how much? The value of v1 is 23.33. v2 you have calculated 22.5 whole square divided by 2 into 1000 divided by 1000, and then this will be also in kilopascal. Is that clear? So if I calculate these things, So you will be getting the value of P2, that is equals to 289 kilopascal. Sorry, approximately 284 kilopascal. Okay. Okay, so after that I'll be moving towards the next question here, and this is inclined differential manometer. So you can see that the pressure differential across a venturi, sorry, this is inclined venturimeter, across a venturimeter inclined at 45 degree to the vertical, right? So this is a vertical line, and if density of the flowing fluid is rho and the density of the manometric fluid is rho m, the velocity of the fluid in the clot. So let's try to understand this question first. So let's say at this particular point, if I apply the pressure balance, so let's say this point is 2 and obviously this point is 1. So what I can say that this point is P1. So P1 plus rho z so from here to here, so best part is if I calculate the height from this point to this point, so this will be your h and sine theta, that is sine 40. Is that clear? And if I am assuming this height is, let's say, h1 and this one is h, and I can balance the pressure at this point. Okay, so I can write the pressure at point here and here, it will be same. So let's say pressure at z and z dash. So pressure at z will be equals to how much? P2 plus rho z h1 plus rho mz h. And what is Pz dash? That is equals to P1 plus rho z h sine 45 degree plus rho z h1 plus rho z h. Is that clear? So pressure at this point will be same. So what I can say, Pz will be equals to Pz dash. So I can say P2 plus rho z h1 plus rho mz h, that is equals to P1 plus rho z h sine 45 degree plus rho z h1 plus rho z h. So let's see which of the following options can cut. So rho z h1 and rho z h1 will get cancelled out, and I can say that P2 minus P1, that can be written as obviously rho z h sine 45 degree plus rho z h minus rho m z h. So P2 minus P1 can be written as rho z h sine 45 degree plus, if I take common gh, so I can write rho minus rho m. Is that clear? So you can write P2 minus P1 divided by rho z, that is equals to h sine 45 degree plus h into 1 minus rho m divided by rho. Okay, great. And after that you can say that if I apply the Bernoulli's equation at point 1 and 2, I can write P1 by rho z plus V1 square by 2z plus Z1, that is equals to P2 by rho z plus V2 square by 2z plus Z2, and obviously Z1 minus Z2 equals to h sine 45 degree. So I can calculate P1 minus P2 divided by rho z, that is equals to V2 square minus V1 square divided by 2z plus Z2 minus Z1. And what is P1 minus V2 by rho z? that is equals to minus h sine 45 degree plus h into 1 minus rho m by rho, that is also in minus because there is minus, that is equals to v2 square minus b1 square by 2z plus again z2 minus z1 will be equals to minus h sine theta h sine 45. So it will get cancelled out. So finally you will be getting value of v2 square minus b1 square divided by 2z, that is equals to h into rho m by rho minus 1. That's it. This will be your answer. Okay. So here whenever these kind of questions are coming, no, you have to understand, you have to do things. One is how to balance the pressure on the same level of liquid, and second thing is that how to apply the Bernoulli's equation at point 1 and 2. If you know these things, definitely this you are going to crack this question. Okay, I hope this question is clear to all of you. Now I will be moving towards the next question. Next question says that losses for flow through valve and fitting are expressed in terms of drag coefficient, equivalent length of the straight pipe, shape factor and roughness factor. So obviously it is expressed in equivalent length of a straight pipe. Now next question says that in a Hazen-Poiseuille's flow through a cylindrical tube, the radial profile of shear stress is. So radial profile of shear stress is, if Hazen-Poiseuille flows are there, so this one is the velocity profile, and if this is the center line, so shear stress profile used to be linear, right? So that will be your linear profile. Now in an orifice meter, if the pressure drop across the orifice is overestimated by 5%, then the percentage error in the measurement is, right? So if you see that percentage measurement in flow rate, so Q is directly proportional to root over delta P, right? So if I say Q1 is directly proportional to root over delta PU, and Q2 will be directly proportional to root over 1.05 delta P. Is that clear? So this one is equation first and this one is second. So what is percentage error? Percentage error, that is equals to Q2 minus Q1 divided by Q1. So if you can write these things, you can write 1.05 minus 1 divided by 1. Okay, and multiply with 100 because you are supposed to calculate in percentage. So that will be equals to 2.469, that will be equals to 2.47%. So you have to use this formula, that is the proportionality based relation, right? Okay, so after that I'll be moving towards the next question, and the next question says that two liquid. Okay, so I'll stop the class up to here only. In the next class, I'll be starting with the next question, right? Because the video will be getting very long and you will get bored because this topic is a bit, calculated topic, okay? So in the next lecture, I'll be trying to complete this particular topic, and after that, I'll be starting with the next topic, that is your laminar flow, okay? Lots of questions have been asked from flow through pipe, so that's why this topic is very, very important. At least 30 questions has been asked in previous year from this topic. So flow through pipe topic is very, very important. In the next lecture, I will be talking about next question from 6.12. Okay, thank you.